Trig here in section 3, doing a third day, and looking here at angle of elevation and angle of depression. And these are just a couple of applications that will use the trigonometry and the trigonometric ratios to find measurements that we can't take directly, find distances that we can't directly measure. Okay? When we talk about angle of elevation, we're always talking about measuring the angle from the horizontal up. Okay? So this would be our theta in this area here, measuring from the horizontal up to the terminal side. And that's our angle of elevation. When we talk about an angle of depression, we're talking about going from the horizontal and measuring down. So this theta down here represents an angle of depression. And that's the one that people will often have trouble with because you forget to start from the horizontal and then measure in a downward direction. So whether you're doing angle of elevation or angle of depression, either one, you have to be starting from the horizontal as your initial ray, as your initial side, and then measuring down to or up to a terminal side, depending on which of the angles we're looking at. Okay? So let's look at a couple of applications. So we have a surveyor standing 50 feet from the base of a large tree. Okay? So how can we represent that in terms of a right triangle? Well, so here's the ground. Okay? Here's our large tree, and the surveyor is 50 feet from the base. Okay? So we're going to put our surveyor out here, and here's our 50 feet. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. So angle of elevation means I have to be looking up. So here's my angle of 71.5 degrees. How tall is the tree? So we're looking for this height. So this goes back to our right triangle trigonometry. I have to use the angle that I'm using as my starting point is the 71.5. The side that I'm looking for, H, is the side that is opposite the angle that I know. The side that I know is adjacent. So if I'm using opposite and adjacent, remember that is the tangent of theta. It is the opposite leg divided by the adjacent leg. Okay. Now in this case, we know what theta is. We know that theta is 71.5. So the tangent of 71.5 degrees is equal to the ratio of the opposite leg, which is h, divided by the adjacent leg, which is 50. So there's our equation, and we just need to solve for h. So to undo or to get rid of that division there, we're going to multiply both sides by 50. So I have 50 times the tangent of 71.5 degrees is equal to my height. So now we're going to go to the calculator. But again, we have to make sure that our calculator is in the same degree mode as our angle. So since our angle is in degrees, I'm going to go to my mode key. I'm going to have to make sure that my calculator is in degree mode. And then I'm going to type in 50 times the tangent of 71.5. I get 149 4/10 feet as my approximate height. So again, just taking 50, multiplying by the tangent of 71.5 degrees, the key being to remember that your calculator has to be in degree mode since our angle was given to us in degrees. Okay? So there's our final measurement for the height, or the estimated height of the tree. Okay? Let's look at another one. Skateboard ramp has an angle off the ground of 18.4 degrees, rises to 4 feet off the ground. Okay? And again, it doesn't matter kind of which direction you're going here. So here's the ground. The angle of the ramp from the ground is 18.4 degrees. And it says that the height of the ramp is going to reach 4 feet off the ground. How long is the ramp? Well, the ramp itself is this piece right up here. Okay? So we're looking for the length of the ramp. So again, we have to look at the angle that we know, the side that we know and the side that we're looking for, and see which of the trig functions that's going to fit. Okay? Well, from my 18.4, the 4 feet is the opposite. The length, or the ramp itself, represents the hypotenuse. So if I'm talking about opposite over hypotenuse, that's the sine function. Okay? So the sine of the angle, which I know to be 18.4 degrees, is the ratio of the opposite side over the hypotenuse. Okay? So we have to solve for L. This time L is in the denominator. So if we were to get rid of the division again, we would have to multiply both sides by L. So I'm going to show that. And what that does is it allows those two L's to divide out. And we have L times the sine of 18.4 degrees equals 4. Well, now how do I get the L to be isolated? How do I solve for L? I've got multiplication there. So in this case, we're going to have to divide by the sine of 18.4 degrees. Remember, that's all one value. I can't split the sine from the 18.4 degrees. It's all one value. And if I divide the left side, I have to divide the right side. Okay? And what I end up with now, the sine 18.4 degrees will divide out. I have the length equal to 4 divided by the sine of 18.4 degrees. And if we go back and take a look at where we started, okay, here's my sine of 18.4, here's L, we can see that all that really has taken place is that those two things switch places. We interchanged the L and the sine of 18.4. And that's always going to happen that way when our variable is in the denominator of that ratio. Okay, so if we just remember that, then we can kind of cut out these extra little steps in here. So now it's simply a matter of going to the calculator. 4 divided by sine 18.4 degrees. And my length of my ramp is approximately 12.67 feet. So again, another application of the trig. So we're going to stop there for today. Just a short little lesson, a couple examples on applying these trig functions. And then we will pick up some more in the next section, looking at how to find the trig values of any angle. Okay. We'll see you tomorrow.